Gəlin bir dənə biz öncə Java garbage collection haqqında oxuyaq. Çünki belə olmaz. Collection, Java. Neydi bu adamın adı? Okay. Bir de harda var o. Okay. Bura baxaq. Yenə bura daha yaxşıdır. Garbage collection'a baxırıq. You have read many articles on garbage collection in Java. Some of them are too complex to understand. Some of them don't contain enough information required to understand. Okay. Aha. A new collector called G1 garbage first and is also introduced in JDK 1.7. The first step to learning about garbage collector is to understand when an object becomes eligible for garbage collection. Since JVM provides memory management, Java developers only care about creating an object. They don't care about cleaning up, which is done by garbage collector. But it can only collect objects which have no live strong reference or it's not reachable from any thread. If an object which is supposed to be collected but still lives in a memory due to an intentional strong reference, then it's known as memory leak in Java. Deməli memory leak nədir? Əgər object collect olunmalıdır, amma bilinməyən bir strong referansına görə, unintentional strong referansına görə memory əgər hələ də qalıbsa, buna memory leak deyilir. Unintentional nə deməkdir? Məqsədli şəkildə olmayan. Okay, thread local variable'lar haqqında oxumalıyıq. Bunu da saxlayırıq. Thread local variables in Java web application can easily cause memory leak. And if you are serious about improving your advanced JVM skills and learning things, advanced Java performance course. Okay. Nice. Deməli, this article is continuation of my previous article, how class path works in Java and how to write the equal methods in Java. And before moving ahead, let's recall a few important points about garbage collection in Java. The objects are created on the heap in Java, irrespective of their scope, like local or member variable. It's worth nothing that class variables or static members are created in the method area of Java memory space, and both heap and method area is shared between different threads. Garbage collection is a mechanism provided Java virtual machine to reclaim heap space from objects which are eligible for garbage collection, relieves Java programmers from memory management, which is essential part of C++, and gives more time to focus on business logic. Carried by daemon thread. Okay, garbage collection is carried by daemon thread called garbage collector. Where garbage collector özü bir daemon thread'dir. Daemon thread'lər nə idi? Daemon thread neydi? Application eğer dayansa, daemon thread işi bitməsə də dayanırdı, düzdür? What's daemon thread? Bir daha bunu dəqiq baxaq. What is daemon thread? Okay. Bütün threadler terminate olanda onlar da terminate olur. Okay. Before moving an object from memory, garbage collection thread, Before moving an object from memory, garbage collection thread invokes finalize method that of that object and gives an opportunity to perform any sort of cleanup required. You as a Java programmer cannot force garbage collection in Java. It will only trigger if JVM thinks it needs a garbage collection based on Java heap size. There are methods like system garbage collection and runtime garbage collection which are used to send requests to garbage collection to JVM, but it's not guaranteed that garbage collection will happen. If there is no memory space for creating a new object in Heap, Java virtual machine throws out of memory error. Okay. Java Standard 2 Standard Edition adds a new feature called ergonomic goal of ergonomics to provide good performance from the JVM with minimum of command line tuning. Okay. Neyse. When an object becomes eligible for garbage collection. Gəldi əsas məsələyə. An object becomes eligible for garbage collection or garbage collector if it's not reachable from any live thread or by any static reference. In other words, you can say that an object becomes eligible for garbage collector if all references are null. Bütün referanslar null'dırsa, garbage collector üçün əl çatandır. Ya da belə deyirik ki, hər hansı bir live thread tərəfindən və ya static reference tərəfindən əl çatan deyilsə. Cycling dependencies are not counted as reference. So if object A has a reference to object B and object B has a reference to object A and they don't have any other live reference, then both object A and B will be eligible for garbage collection. Okay, nə deyir? Gəl bir daha. Neydi o? O mən... Okay, bu niyə belə elədi? Nəsə, deyir ki, bizim tutaq ki, bir dənə burada stackimiz var və bir dənə də belə heapimiz var. Bizim heapdir. Deyir ki, burada A objekti var. Burada bir dənə A objekti var. Bir dənə də B objekti var. Bunların ikisinin də bir-birinə referansı var. Amma stackdən bura heç bir referans yoxdur. Belə olan halda bundan buna referans var, amma buradan heç bir referans yoxdur. Stackdən heç bir referans yoxdur. Belə olan halda A və B hər ikisi eligible'dır. Deməli, Java Performance Definitive Guide bu kitab middle səviyyə şeylər üçün yaxşıdır. Çox sağ olun, onu qeyd edirəm. Okay. Generally, an object becomes eligible for garbage collection in Java in the following case. All references to that object are explicitly set to null. Object is created inside the block and reference goes out of scope once control exists that block. Həmin o, deməli, metod stackdən metodun deməli hər bir execute olunduqca gedir, onu nəzərdə tutur. Parent object set to null if an object holds the reference to another object and when you set container object reference null. Child or contained object automatically becomes eligible for garbage collection. If an object has only lived a weak reference via weak hash map, it will be eligible for garbage collection. Okay. Heap generations for garbage collection in Java. Aha, gəldi indi bura. Deməli, Java objects are created in Heap and Heap is divided into three parts or generation for the sake of garbage collection in Java. These are called young generation, tenured or old generation, and perm area of Heap. New generation is further divided into three parts as known as hidden space, survivor 1 and survivor 2 space. Okay, deməli, young generation, tenured, old generation. Young generationda 3 hissəyə bölünür. Hidden, survivor 1 və survivor 2. Young, old, permanent. Youngda da hidden When an object is first created in Heap, it's created in new generation inside hidden space, and after subsequent minor garbage collection, if an object survives, it gets moved to survivor 1, then survivor 2 becomes major garbage collection and move that object to old or tenured garbage collection. Java 7-dən sonra perm yoxdur. Okay. Bu nə vaxt yazılıb? 2022-də. İndi baxarıq. In Java, specifically in version prior to permanent generation, was a dedicated area of heap memory. With Java 8, perm generation was removed and replaced by metaspace. Okay, metaspace-dən əvəz olunub. Çox sağ olun. Metaspace stores class metadata natively in the operating system's memory rather than in a fixed size area of the Java heap. This change largely eliminates the out of memory perm space error because metaspace can dynamically expand its size based on available native memory, unlike perm gen, which had a fixed maximum size. Həm də configurable'ymış. Deməli, niyə remove olunub? Çünki static fixed imiş və fixed olduğu üçün belə bir out of memory error, perm generation space error verilmiş. Daha sonra onu dəyişiblər, metaspace-lə əvəz ediblər. Metaspace-də operating sistemin özündədir, səhv eləmirəmsə. Operating sistem memorisindədir və fix bir size yoxdur. Bu fix bir size yoxdur. İşte. Və size də dinamik olaraq dəyişir. Native memory'nin, yəni operating sistemdəki memory'nin asılı olaraq. Available native memory. Okay. Permanent generation of heap or perm area of heap is somewhat special and it's used to store metadata related to class and methods, and JVM also hosts a string pool provided by JVM as discussion in my string tutorial. Deməli, there are many options whether garbage collection in Java happen in the perm area of the Java heap or not. As per my knowledge, this is something that's JVM depends and happen at least in Sun's implementation of JVM. You can also try this, just creating million of string and watching for garbage collection or out of memory error. Okay, types of garbage collector in Java: concurrent versus serial garbage collector. Bu biraz köhnə görünür. Başqa bir tapıb oxuyaq. Görüb nə vaxt yazılıb? 2025. Buradan oxumaq da heç güvən vermir. Okay. Okay. Class loader subsystem. Automatic garbage collection. Are used, which are not deleting unused object. No longer reference. Okay. Aha. Birinci step marking. Okay, burada daha yaxşı yazılıb. Okay, cool. Birinci step nədir? First step in the process is called marking. This is where the garbage collector identifies which piece of memory are in use and which are not. Before marking, belə bir şey. After marking, a live object, unreferenced object, and memory space. Referenced objects are shown in blue, unreferenced objects shown in gold, and all objects are scanned in the marking phase to make this determination. This can be very time-consuming process if all objects in a system must be scanned. Deməli, bütün obyektlər nə olur? Scan olur. Normal deletion. Normal deletion removes unreferenced objects, leaving referenced objects and pointer to free space. Leaving referenced objects and pointers to free space. Və normal deletion baş verir sonra. Normal deletiondan sonra nə olur? Buradakı unreferenced objektləri silinir. Memory allocator holds a list of references to free spaces. Okay. Memory allocator boş olan yerlərə referanslarını özündə saxlayır. And search for free spaces whenever an allocation is required. Nə vaxt ki, hansı obyekti yerləşdirmək lazımdır, free space üçün axtarır. The memory allocator holds reference to block of free spaces when a new object can be allocated. Deməli, təmizləyəndən sonra, mark phase'dən sonra, mark olunan obyektləri təmizləyəndən sonra boş yerləri saxlayır ki, təzə obyekt yaradanda onları bura qoya bilsin. Deletion with compacting. Compacting baş verir. Compactingdə nə edir? To further improve performance, in addition to deleting an unreferenced object, you can also compact the remaining referenced object. By moving referenced object together, this makes new memory allocation much easier and faster. Deməli, burada qalan boş yerləri nə edir? Sıxışdırır bunları bir yerə ki, boş yerlər getsin. Memory allocator holds the reference to beginning of free space and allocate memory sequentially then on. Memory'ni ardıcıl olaraq yerləşməsi üçün bunların hamısını başlanğıca itələyir. Why generational garbage collection? As stated earlier, having to mark and compact all objects in JVM is inefficient. As more and more objects are located, the list of objects grows and grows, leading to longer and longer garbage collection time. Hər dəfə bu mark phase-də nə olur? Bütün hamısını bu gedir, axtarır və mark edir, düzdür? Sonra bütün o obyektləri belə itələmək filan bu vaxt alır. Ona görə gəlib belə bir şey eləyiblər. Bunlar collectionlar generational eləyiblər. However, empirical analysis of application has shown that most objects are short-lived. Here is an example of such data. Y-axis shows the number of bytes allocated and x-axis shows the number of bytes allocated over time. Burada bu qədər yaşayıb, daha sonra bu qədər. Getdikcə bunların yaşamı vaxtı azalıb. As you can see, fewer and fewer objects remain allocated over time. In fact, most objects has very short life as shown in the higher values of left side of the graph. JVM generations, okay, burada da permanent göstərir. Well, the information learned from object allocation on behavior can be used to enhance performance of JVM. Therefore, the heap is broken into smaller parts or generations. Parts are young, old, and tenured generation and permanent generation. Young, old veya tenured generation ve permanent generation. Okay. 3 də nədir? Young, old, permanent. Young generation is where all new objects are allocated and aged. When young objects flips up, this causes a minor garbage collection. Təzə obyektlərin olduğu yer nədir? Young'dır. Young generation dolanda bu minor garbage collection-na səbəb olur. Kiçik bir garbage collection baş verir. Minor collection can be optimized assuming a high object mortality mən nə deyirəm?
Mortality.
Okay, mortality. Ölümcülük. Mortality rate. A young generation full of dead objects, it's collected very quickly. Some surviving objects are aged and eventually moved to old generation. Aha. Young'da survive olanlar old'a keçir. Stop the world event. Okay. All minor garbage collections are stop the world event. Yəni bütün kiçik garbage collectionlar fərqi yoxdur hansı generationda baş verir. Stop the world eventdir. Yəni garbage collection baş verəndə application'dakı digər heç bir şey nə eləmir? İşləmir, davam eləmir də, dayanır bir müddət. This means all application threads are stopped until operation completes. Minor garbage collections are always stop the world event. Okay. The old generation is used to store long surviving objects. Typically, a threshold is set for young generation objects, and when that age is met, objects get moved to old generation. Eventually, old generation need to be collected. This event is called major garbage collection. Okay, nə deyir? Deyir ki, young generation'da olan obyektlər üçün bir dənə threshold set olunub. Nə vaxt ki, obyektlər həmin dövrü keçir, onlar keçirlər hara? Old generation'a. Old generation'da baş verən garbage collection'a da deyirik major garbage collection. Major garbage collection həmçinin stop the world eventdir və often major garbage collection is much slower, daha yavaşdır. Çünki it involves all live objects. So for responsive applications, major garbage collection should be minimized. Also note that length of stop the world event for major garbage collection is affected by kind of garbage collector that is used for old garbage collection. Deyir ki, bu major garbage collection daha uzun çəkir. Niyə? Normalda bizim old generation'ımızda obyektlərin sayı daha çoxdur, düzdür. Artıq orada eligible olan obyektlər də var. Amma bu obyektlərin çoxu nədir? Çoxu live referansı olanlardır. Ona görə çox çəkir burada. Və deyir ki, böyük applicationlarda major garbage collector daha şey olmalıdır, azaltılmalıdır da. Çox olmamalıdır. Azaltılmalıdır deyəndə nə deyir? Minimized, yəni az olmalıdır da. The permanent permanent generation contains metadata required by JVM to describe the classes and methods used in the application. The permanent generation is populated by JVM at runtime based on classes in use by the application. Ne deyir? In addition, Java library classes and methods may be stored here. Classes. Okay. Nə deyir? Deməli, yuxarıda overview'da yazılıb ki, bu tutorial Java 7 üçün yazılıb. Perm yenə yoxdur metadata. Perm yenə yoxdur metadata söhbətinə görə. Okay, harada yazılıb Java 7 üçün? Overview'a bir dənə baxaq. Okay. Bəs indi biz bunu necə görək? Java 7. Oy. Yox. Sonuncu versiya üçün olan. Okay. Bu da 11'dir. Okay. Okay. Sadəcə prim çıxarıblar, yəqin onda bütün hamısı eynidir. Okay, oradan oxumağa davam edəyək, çünki orada daha yaxşı yazılıb. Time, comparing percentage of time spent in garbage collection. Okay. Hə, burada da vardı. Burada da yazılıb implementation. Okay. Burada göstərib ki, young və old. Garbage, first garbage collector. Okay. Neyse, bu hissəni bir dənə tamamlayaq. Burada qəşəng göstərmişdilər. Classes may get collected, unloaded if... Bir dəqiqə soruşarlar. Hə, sonra inşallah gəldim geri. Səsim gəlir? Hə, okey. Aha. Okay. Nəyi siləcəyini garbage collector özü müəyyənləşdirir, amma referanslara yön verə bilirik. 4 növü var. Strong, soft, weak və phantom. Referans özümüz işarə verə bilirik necə işləsin deyə. Okay. Bu haqda hardan oxuya bilərəm daha ətraflı? Əslində bu tapdıq burada sonuncu üçün olanı sadəcə sıxıcı görünür burada. Belə qəşəng yazsınlar da nə qəşəng şəkillərlə falan göstəriblər. Heap separated into different generations. It's time to look at how exactly these spaces interact. Follows walk through the object allocation and aging process in JVM. First, any new objects are allocated to the hidden space. Both survivor space start out empty. Hər ikisi boş olur. Burada hidden de olur. Daha sonra oradan gəlirlər bu tərəf. When hidden space is filled up, minor garbage collection is triggered. Minor garbage collection. Reference objects are moved to first survivor space, and reference objects are deleted when hidden space is cleared. copying referenced objects. At next minor garbage collection, the same thing happened for the hidden space. Unreferenced objects are deleted and referenced objects are moved to survivor space. However, in this case, they are moved to second survivor space. In addition, objects from the last minor garbage collection on the first survivor space have their age incremented and get moved to S1. Once all survivor objects have been moved to S1, both S0 and hidden are cleared. Notice we now have differently aged objects in the survivor space. Object aging 0, 1, 2. At the next minor garbage collector, same objects process repeat. However, this time survivor spaces switch. Referenced objects are moved to S0. Surviving objects are aged, hidden and S1 are cleared. This slide demonstrates promotion after minor garbage collector. When aged objects reach to certain age threshold, 8 in this example, they are prompted from young generation to old generation. Deməli nə olur? Bu survivor space'lər arasında minor garbage collection'lar baş verdikcə yerlər dəyişir. Və nə olur? Daha doğrusu buradan bura və ya hər ikisindən bura, bir dənə survivor'a gedir. Sonra müəyyən thresholda çatan sonra gəlirlər tenured olana. Continue to occur, object will continue to promote to old generation space. So that pretty much cover the entire process with young generation. Eventually, major garbage collector will be performed on old generation, which clean up and compact the space. Okay, well. Let's see. Okay. Object life cycle management. Çok sağ olun. Bu compaction'ı göster. Dört tane farklı garbage collector algoritmi var. Serial garbage collector, simpler of 4, use single thread to process heap, stop all application threads as the heap is processed. During full garbage collector, it will fully compact the old generation. Serial collector is enabled by using Well, çətin görünür. Burada çox yazı var. Hansını oxuyam bilmirəm. Generational garbage collector. Buna bax, biz bayaq buna baxırdıq. Split heap into different generations. These are called old generation and the young generation. Okay, burada deyir old və young generation. Kitabda çox detallı yazılıb, search etmək daha yaxşıdır. Ya, bir dənə burada generational olan hissəyə baxaq. Görə burada nə yazıb o haqda. Young generation is further divided into sections known as hidden and survivor spaces. The rationale for having separate generations is that many objects are used for very short period of time. Okay, bunu oxuduq. Immutable. Well, stop the world from bunları oxuduq. Gedək elə Oracle'ın özündən oxuyaq. Okay, garbage collector'ı biz bildik. Bizə əsas lazım idi bu. Burada bizim çətinlik var idi. Suallara cavab verə bilmirdik. Garbage collector'ı bildik. Thread local'a baxaq bir dənə. Ondan sonra GPT-nin verdiyi sualına davam edək. Elə buradan davam edəkmi? Aha. Okay. Usually hidden promoted to survivor old generation because a long-running task keep reference alive. Okay, biz bunu deməliyik. Necə baş verir garbage collector? Garbage collector sees the reference in the worker thread stack frame. Therefore, the list is strongly reachable and cannot be collected. When the task finish and method stack is removed, reference disappears, list becomes unreachable, eligible for garbage collector, and the next young old generation cycle. No collection happens while task is executed unless reference is dropped early. Okay, biz garbage collector'ı bildik. Bir dənə baxmalı olduğumuz hissə thread local'dır. Thread local. Okay. Thread local. Thread local. Okay. Thread local is a variable type of thread local, which each thread that accesses a thread local variable has its own independent initialized scope of variable. To write read thread local variable value is called set and get method respectively. Bir dakika, bize bu thread local hakkında neyi deməlisən dedi burada. You didn't mention thread local allocation, escape analyze, and fact that array list cannot be stack allocated. Thread local allocation nədir? Biz buna baxaq. Okay. Görə nədir? Aha, baxırıq. Deməli, whenever we do this, the most obvious is the new keyword, but there is others. For example, using reflection. Okay, reflection oxumaq lazımdır. Whenever we do this, JVM must set aside some memory for the new object on the heap. In particular, JVM memory allocation does all the allocation in this way in the hidden or young space. In a single thread application, this is easy, since only a single memory allocation request can happen at a time. Thread can simply grab next block of suitable size and we are done. String array list hidden space yaradılıb. However, in a multi-threaded application, we can't do this. We can't do things quite so simply. If we do, then there is the risk that two threads will request memory at the exact same instant and will both be given the exact same block. Okay. İki thread belirləyəndə olmur. To avoid this, we synchronize memory allocation so that two threads cannot request the same memory block simultaneously. However, synchronizing all memory allocation will make them essentially single-threaded, which can be a huge bottleneck in our application. Deməli, thread local allocation buffer. The JVM addresses this concern using thread local allocation buffer or TLBS. These are areas of heap memory that are reserved for given thread and are used only by that thread to allocate memory. Okay, cool. Thread local allocation budur. Deməli, thread local allocation nədir? Hər bir threadin özünün thread lokalı olur. Hansı ki memory'si olur. These are areas of heap. Thread local allocation heap'dədir. Thread local allocation heap'dədir. Və hər bir thread üçün var. Məqsəd də odur ki, iki thread eyni anda bir dənə yeri tutmasın. Sonra problem yaratmasın. Və bunlar da nə edir? Hidden space'də olur. Yəni heap'dədir, stack'də deyil, heap'dədir. Thread local allocation. Thread local heap'dədir. Okay. Thread local deyəndə çox vaxt mənim ağlıma stack gəlirdi. Niyə? Çünki hər bir threadin özünün stack var da, düzdür? Amma deməli hər bir thread üçün heap'də də thread local ayrılıb. Well, by working in this way, no synchronization is necessary since only a single thread can pull from this buffer. The buffer itself is allocated in synchronized manner, but this is much less frequent operation. Since allocation memory for objects is a relatively common occurrence, this can be huge performance improvement, but how much exactly? We can determine this easily enough with a simple test. Belə bir allocation test edir, start edir, array list, objektləri add edir, project size. This is a relatively simple test, but it does the job. We're going to allocate for 1 million object instance and record how long it takes. We can run this in number of times, both with and without. Thread local'la daha az bir vaxt, thread lokalsız daha çox bir vaxt sərf olunur. We can clearly see the difference. Average time bunda 33'dür. Bunda nədir? Çoxdur. 100'dür, 110'dur. Running out of thread local buffer space. Obviously our thread local allocation buffer mı? Allocation buffer mı deyir? Nə deyir? Allocation buffers. Is finite. Yəni infinite deyil, finite. So what happens we run out of? Yəni run out of eləyəndə nə baş verir? If our application tries to allocate space for new object and thread local allocation buffer doesn't have enough available, JVM has 4 possible options. It can allocate a new amount of thread local allocation buffer space for this thread, efficiently increasing the amount available. It can allocate memory for this object from outside of thread local. It can attempt to free up some memory using the garbage collector. It can fail to allocate the memory and instead throw an error. Okay, 4 proses baş verir. Thread local'ın areasını genişlədə bilər. Thread local'ın çölündə saxlaya bilər. Garbage collector'ı çağırıb thread local təmizləyə bilər. Ciddi ümumiyyətlə memory'ni təmizləyə bilər. Thread local da orada gedir. Və ya allocate eləyə bilmir və exception atır. Option 4 is our catastrophic case, so we want to avoid it. whenever possible, but it's an option if the other cases can't happen. JVM use a number of complicated nəsə bunu oxuya bilmədim, to determine which of the other options to use, and this may change between different JVMs and different versions. However, the most important detail that fit into decision include deməli qərarı necə verir JVM, a number of allocations that are likely in a period of time. If you are likely to be allocating a lot of objects, then increasing thread local space will be more efficient choice. Əgər çox obyekt saxlayırıqsa, thread local artırmaq daha yaxşıdır. If we are likely to be allocating very few objects, then increasing thread local might actually be less efficient. Əgər çox obyekt saxlayacaqsa artırmaq yaxşıdır, az obyekt saxlayacaqsa yaxşı deyil. The amount of memory being requested, the more memory requested, the more expensive it will be allocated outside of thread local. Başa düşmədim. Əgər çox memory request olsa, the more expensive çox memory tələb olunsa, bunu çölündə saxlamaq thread localın daha expensive olacaq. The amount of available memory. If JVM has lots of memory available, then increasing space much easier. If the memory space is very high, eğer yer çoxdursa, bu thread local artırmaq okeydir. Amount of memory contention, lots of thread, then each need memory, then increasing might be much more expensive if there are very few threads. Çox thread varsa artırmaq yaxşı deyil. Deməli, bir neçə qərar verir bir neçə şeyə əsasən. Okay. Thread local allocation buffer seems like fantastic way to improve performance, but always cost. Synchronization needs to prevent multiple threads from allocating same memory area. Relatively expensive to allocate. I also need wait for sufficient memory to be available. Usage is especially high. JVM usage, memory usage yüksekti. If thread allocated a large amount of memory for its thread local space then memory will just sit there unused and it's essentially wasted. Daha çox əgər thread locala yer versək, lazım olandan waste olacaq, yaxşı deyil. Worse, wasting the space make it much difficult other thread obtain memory for local spaces and make the entire application slower overall. Deməli, burada müəyyən bir şey var ki, nə qədər space allocate eləməlidir. Allocate too much and we are wasting space. Allocate little, we spend more time than it's desirable allocating lokalda. JVM də bunun hamısını bizim üçün eləyir. Well, məncə bu qədər enough'dır. Bu qədər bəsdir. Getdi indi GPT-mizdən davam eləməyə. Okay, biz thread localı bildik. Escape analyze bunu bildik. JVM garbage collector necə eləyir? Array list də harda saxlanılır? Heap də saxlanılır. Okay, bunu da bilirik onsuz da. Garbage collector sees reference in the worker thread stack frame. Therefore, the list is strongly reachable, cannot be collected. When the task finish and method stack frame is removed, reference disappear, eligible, no collection happens.